in figure a plate of mass 5 kg is connected to a weight with a mass of 10 kg using threads P and Q. The system is in equilibrium. In figure B, two objects A and B, each with a mass 1 kg, are gently placed on the plate simultaneously. The system remains in equilibrium after this placement. The acceleration due to gravity is supposed to be taken as 10. The plate is parallel to the horizontal surface. The mass of the threads and all frictional forces are neglected. And based on this question, we have these three statements. First is, in figure A, the magnitude of the force Q exerts on plate is 50 Newton. In option number statement B, the magnitude of force P exerts on the plate is same in both A and B, figure A and B rather. And third statement is, magnitude of the force in Q exerts on the plate is greater than A and in B. So this is our figure A and this is our figure B. So in figure A, we have one is a plate which is connected with the string P and Q, and through this pulley system, another mass, and its mass value is given as 10 kg. So we have plate mass is 5 kg. So we have this plate which mass is 5 kg and 10 kg, and they are connected with this string. In the figure B, additional mass of A and B are placed on the plate, and in both the cases it is given this entire system is in equilibrium. So let us solve one by one for the given condition. So let us start from figure A. So we say from figure A, we assume that the tension force as acting, let us suppose here it is Tp. So as this is a single string and mass 10 is connected with mass of 5 kg with the same string, so obviously here also there will be a tension of Tp. So both the cases there will be a tension of Tp. And for the mass of 10 kg in the downward direction, we are going to have a force that will be equal to mg. Okay, here m is equal to 10. So as the entire system is in equilibrium, so we can say our Tp is equal to mg for 10 kg system. Okay. So we say for in figure A, for 10 kg, the force acting in the downward direction is our, let us suppose that is given as F10. Force acting on 10 kg in downward direction. Let us suppose that is given as F10. So we can write our F10 will be equal to m multiplied by g, and this comes as 10 multiplied by 10, which gives us that our F10 will be equal to 100 Newton. And it is given that the entire system is in equilibrium. So we say as the system is in equilibrium, Tp, that the tension in the string, or we can say Tp, will be equal to 100 Newton. Now let's make the analysis for 5 kg. For 5 kg, the force acting on the 5 kg force acting on 5 kg in downward direction one will be, let me draw here, this is our block of 5 kg. In the downward direction we are going to have mg. So let me write that force is suppose given as F5. So F5 will be equal to m multiplied by g. Here mass is 5 multiplied by 10, so this gives us 50 Newton. And in the upward direction we are going to have tension Tp, and this is also connected with the string, so also there will be a tension because of Q string. Let us call that as tension as Tq. And this 5 block is also in equilibrium. So it is given that 5 kg block is in equilibrium, therefore all the forces will be balanced. So upward direction we are having a Tp, and in the downward direction we have two forces. One is our F5 and another force is acting over Tq, that the tension in Q string. So from here Tp we already know is our 100, F5 we just calculated 50, and this comes as Tq. So therefore we can write that our Tq will be equal to 50 Newton. So this is our tension in Q string. Tension in Q string. Now we made this entire analysis only for figure A. Now we start for the similar analysis for figure B. So we have for figure B. Now in figure B, the mass of 10 kg, there is no change. So this is 10 kg mass, it is same. So once again we assume that tension here it is Tp. So obviously other side also we are going to have Tp. In the downward direction we are going to have a force of mg. So we can write that, let me draw a 10, let me first write it, that for 10 kg mass there is no change. So this is our 10 kg. Here we are going to have tension Tp. Downward we are going to have mg. So once again we can say that our Tp will be equal to mg. Tp will be equal to mg. M is our 10, g also is 10. So this gives us that tension Tp will be equal to 100 Newton. And this we did for figure B for mass 10 kg. 10 kg. Now let us do, you can say, for 5 kg. For 5 kg. Now for 5 kg, there is slight addition of two weights. So we have this tension Tp, two weights each of 1 kg A and B are added to it. So this is our weight 5 kg, and here there is a Q string which we assume that its tension is our TQ. So for 5 kg, now there will be additional forces that will be acting in the downward direction. One will be this of 5 kg. The downward direction we are going to have this mg, and because of this A, also there will be in downward direction, we call that as mag, and because of B we are going to have mbg. So if the entire system, let us call this as TQ prime. So we just proved that TP is same, so there is no need to change the variable for TP. So once again it is said that even the weights when placed A and B, the entire system is still in equilibrium. So we say for 5 kg, after placing A and B, the system is in equilibrium. So if it is in equilibrium, you can say downward forces will be equal to upward forces. So we get from here, upward we are going to have only one, that is our TP. So TP will be equal to mag plus mbg plus mg and plus T prime Q. Now we simply substitute the values. Tp is our 100, Ma is given as 1, so 1 multiplied by 10 plus 1 multiplied by 10, and this is our 5 multiplied by 10, and this comes as Tq prime. So we can find out that our Tq prime will be equal to this become 100 minus this is our 50 and become this as 70. Okay. This will be 100 minus 70, which comes as 30. Therefore, TQ prime is equal to 30 Newton. So let us check the options that are given to us. Okay. So first option states that in figure A, the magnitude of the force Q exert on the plate is 50 Newton. So it means the tension TQ is our 50 Newton. And this is for figure A. Okay. And we just proved that tension TQ is our 50 Newton. So this statement is true. Part A. So you can say part A is our true. Part B states that the magnitude of the force P exerts on plate is same in both A and B. So it states that force exerts P exerts on the plate in both the cases same. So we just found out in the first case that TP is our 100 Newton, and also in the second case we found out that still TP is equal to 100 Newton. So in both the cases it is force is our 100 Newton. Tension in the P is of 100 Newton. So this statement is also true. And in the final part, it says that magnitude of force Q exerts on plate A in figure A is greater than in figure B. Okay. So which basically means that we previously found out that our TQ was equal to 50 Newton, and in figure B we found out that our TQ prime is equal to 30 Newton. So if you make comparison from here, we can say our TQ is greater than TQ prime. So this statement is also true. So from here we can say that statement A, B and C all are true. So this question was relatively easy, but using a little bit of, you can say, tricky to understand how the system is in equilibrium. So this completes the question. Thank you.